non-decreasing and boundedness, right? We just did one question of non-decreasing and bounded from above, and we saw yesterday the theorem was there which was telling us that if we have a non-decreasing sequence, so the first condition to apply that theorem is that sequence should be non-decreasing, and then the next condition is if it is non-decreasing sequence, then, or you can say the statement like that, a non-decreasing sequence is convergent if and only if it is bounded from above. I'm writing in short, but because we have seen this already in yesterday's lecture. So we did one example. That example was 3n plus 1 by n plus 1. So we checked that it was coming out to be non-decreasing. So that means we could apply this theorem. And then we checked the boundedness. So how did we check the boundedness? We just manipulated it in this way. I just wrote it like 3n plus 3 by n plus 1 minus 2. So this was 3 minus 2 by n plus 1. So this is less than 3. So that means because bounded की जो definition है वो ये है कि आपको एक number अगर दिख रहा है कि sequence की सारी terms उससे कम है, then you can try to get that number. So it's always better to express sequence in this form, that it's some number minus something positive. So वो sure हो जाएगा कि वो सारी terms उससे कम है. So ये एक एग्जाम्पल था. फॉर एग्जाम्पल आई गिव यू अनदर एग्जाम्पल जिसमें आप सेम तरीके से बाउंडेडनेस चेक कर सकते हो. से इट इज दिस 5n plus 1 by 4n. Let's see whether this is bounded or not. I do not know whether it is bounded or not. Let's see whether we can have this or not. So 5n can be written like 4n plus n plus 1 by 4n. So that is 4 plus n plus 1 by 4n. So this is 4 plus something, right? It is plus something. So this way I cannot get it because ये 4 में कुछ plus आ रहा है, so I cannot get that. और वैसे भी अगर आप इस पे otherwise what I'll suggest, अगर हम इसको limit वाले method से करेंगे 5n plus 1 by 4n, right? So you can see, yeah, so you can tell me the value of this limit. Okay, yeah, thank you for correction. Yeah, this is 1 plus this number, but this is 1 plus something, right? But 1 plus something say I cannot have this kind of implication. So the answer of this limit is 5 by 4. Yeah, all of you can solve that. ये easy होता है solve करना. 5 plus 1 by n over if I divide by n, this is 4, so this is going to be 5 by 4. So the answer of this limit is 5 by 4. So you know, if the limit is turning out to be existing, so ये और ये non-decreasing sequence है, so that means this is convergent and this is converging to its least upper bound. So in the cases, in those examples where we are not able to see the bounds this way, so what we do is हम लिमिट से डायरेक्टली निकाल लेते हैं. बट ये आपको उसी केस में ये ट्रिक चलेगा जब सीक्वेंस नॉन डिक्रीजिंग है, राइट? देन यू कैन यूज द लिमिट वे. सो देन दिस इज गोइंग टू बी द लीस्ट अपर बाउंड. सो दिस इज ऑलवेज गोइंग टू बी लेस देन 5 by 4. आप इसको ऐसे भी लिख सकते थे 5n plus 1 by 4n, 5n by 4n plus 1 by 4n. So this is 5 by 4 plus 1 by 4n. तो इसका मैग्नीट्यूड जो है कम होता जाएगा, but the terms are going to be less than equals to that. So this way you will get that. So I'll come to this in detail. Let's do another question. आपको ये बिल्कुल clear हो जाएगा that how exactly we are going to do this one, right? So okay, so yeah, what I'm going to do is I'm going to ask you a question, so you need to put answers here. Yeah, you may have different techniques. So this is a question which you will see in front of you. All of you are just need to solve that. Just take 1 minute at the max, or 30 seconds will be sufficient. Okay, you take 1 minute and answer that question. So this is a question which you are seeing in your screen. This is the sequence. I have given a particular sequence. An is the general term. It's 1 minus 1 by n. So is this non-decreasing? So you have to choose one of the options. कांट से मैंने इसलिए लिखा है, अगर किसी को क्लियर नहीं है कॉन्सेप्ट कि कैसे चेक करते हैं, तो ही और शी कैन चूज द ऑप्शन ऑफ कांट से, बिकॉज मुझे क्लियर हो जाएगा कि आप लोगों को अभी समझ नहीं आया है. सो आई विल एक्सप्लेन अगेन. दिस इज ओनली फॉर नॉन डिक्रीजिंग. Right, I need you to solve this one and then you mark this one. There is no hurry, you take your time. I've given you 1 minute. Yes, n belongs to natural numbers only. And my suggestion will be, do not guess this one. You calculate this the way I had explained you in yesterday's lecture. This is not for guessing. This is for, actually you need to solve this and get me an answer. Yes, last 30 seconds everyone has. Yeah, so exactly at 3 minutes, I'm going to stop this one. Pranshu, elaborate your question. I didn't see that. I didn't get that. Okay, I'm going to end this poll. And if I share the results with all of you, so you can see most of you have answered yes, which is the correct answer. It is a non-decreasing sequence. So I'll just explain in 1 minute how it is going to be like that. It's very easy to do the calculation. So all of you see this. This was the sequence. An is 1 minus 1 by n. So non-decreasing के लिए हम ऐसे check करते हैं. An plus 1 minus an हम check करते हैं. So 1 minus 1 by n plus 1 minus 1 minus 1 by n. So 1 minus 1 by n plus 1 minus 1 plus 1 by n. So actually you are going to get it's 1 by n minus 1 by n plus 1. वैसे तो आप यहीं पे लिख सकते हो this is positive because हमें पता है n जो होता है n plus 1 से छोटा है. So 1 by n will be obviously greater than 1 by n plus 1. So this is positive. और elaborate करना चाहते हो तो लिख सकते हो n plus 1 minus n into n plus 1. So this will be 1 over n into n plus 1. So now we are definitely sure this is greater than equals to 0. Right? So that proves that since your an plus 1 minus n is greater than equals to 0 for all n, do not forget to write for all n. Therefore, this sequence is non-decreasing. Yes, I hope that is clear. No, you cannot simply write non-decreasing just by looking. This is what you need to all practice. That's why I say आपको दिख रहा है बहुत बारे सीक्वेंसेस और सीरीज आपको ऐसे मिलेंगे कि हमें पता होता है कि हाँ ये है नॉन डिक्रीजिंग, बट यू हैव टू शो इट मैथमेटिकली बिकॉज जो वी कांट एनकरेज दैट टेक्निक कि आप इंट्यूटिवली उसको देख के समझ के गेस करो, बिकॉज कुछ सीक्वेंसेस कॉम्प्लेक्स होते हैं वो मेयरली देखने से समझ नहीं आएंगे. So unless or until you do not practice this technique for simple question, you will not be able to apply this on a difficult question. So it is discouraged that you try to give your answer just by looking. That can be a guess. Sometimes it can go right and sometimes it can go wrong. And if you ask from the examination point of view, so in examination also what happens, you will get marks. Let me tell you the practical thing. You will be getting marks only when you explain it mathematically, you justify, because the examiner cannot read your mind, right? What was going on in your mind by writing that. You could have just made a guess. How can we are supposed to check whether you know the concept or not? So for everything, this is not for only this is for every concept you learn. You will be having a well defined mathematical formula to check that. So you have to do it this way or that way only, right? So yeah, yes, I explained you yesterday also that you can do it with the way of um, differentiation also. Yeah, I'm just disabling the chat right now. Wait a minute, let me share this again. Yeah, so let me go back. Let me go ahead. This was the first example. So let me continue with this example. So what we are going to do here is the same example I need to continue. So we already see that this is non-decreasing. So can you see whether this is bounded or not? So bounded, it is very easy to see because it's already written in a form 1 minus 1 by n. I can see that this is less than 1, right? Because this 1 by n is always going to be something positive. So this 1 में से आप कुछ positive subtract कर रहे हो तो the quantity is always going to be less than 1. So this is happening for all n. So since your an is less than 1 for all n, so this is your definition of bounded from above. So therefore this sequence is non-decreasing and bounded from above. Therefore by your non-decreasing sequence theorem, right, this an is convergent. So we did the second example. कल वाले एग्जाम्पल में भी कन्वर्जेंट आ रहा था, ये वाले एग्जाम्पल में भी हमारे पास कन्वर्जेंट आ रहा है. यहाँ पे हमें लिमिट देखने की जरूरत नहीं पड़ी, हमें थ्योरम से ही पता चल गया कि dn is convergent. But if you want to write, because you should write कि convergent है, but what is the limit of that sequence, then वो कैसे निकालोगे? So that you have to find it this way only, limit n tending to infinity an. So limit n tending to infinity, 1 minus 1 by n is 1. It is very clear. So this sequence is convergent to 1. So that's your answer for this question. This is non-decreasing, this is bounded from above, and this is therefore convergent and convergent to 1. और वो 1 कैसे आया? लिमिट निकाल के, right? तो आई विल सजेस्ट यू लिमिट आप हमेशा लिमिट से ही निकालोगे. ऑल्दो हमें पता होता है कि लीस्ट अपर बाउंड को कन्वर्ज करता है, बट जब हम सिर्फ बाउंडेडनेस चेक कर रहे हैं तो यहाँ से हमें क्लियर नहीं होता है कि ये जो बाउंड आया है ये लीस्ट अपर बाउंड ही है कि कोई दूसरा अपर बाउंड भी हो सकता है. तो जब भी आप क्लेम करोगे कि कोई सीक्वेंस किसको कन्वर्ज कर रहा है, सो यू हैव टू हैव चेक दिस इन दिस वे, कन्वर्जेंट टू वन वे. Right, so that finishes our second question. So let's move to the third question. One more example we are going to do of the non-decreasing and bounded, and after that we'll move to the next thing. Yes, so, wait a minute, I will end this poll. I'll just need to ask another question. So again, you are looking at a question in front of you. This time the sequence is 2 raised to power n minus 1 by 2 raised to power n. This is the sequence. You need to answer whether this is bounded from above or not. So take your time and then you answer that. Do not make guesses, I will say. Take a time to grasp the concept of bounded from above and then you answer this question. Bounded from above, अभी मैंने explain किया है that if you are able to see something, number सारी terms उससे छोटी हैं, so if you are able to see any such number, so then you will declare your sequence is bounded from above. Please be honest in answering, क्योंकि फिर मेरे को पता नहीं चलेगा कि actual में कितने लोगों को clear हुआ है. या नहीं हुआ है. ये बहुत सिंपल एग्जांपल्स हैं सभी, तो आपको पहले इनमें क्लैरिटी होगी, ओनली देन यू विल बी एबल टू अप्लाई इट टू डिफरेंट एग्जांपल्स. Yeah, last 30 seconds you have to answer this. Yeah, so I'm going to end this one question and sharing the results with you. Yeah, so this is, most of you have answered it correctly. This is bounded from above, and it's easy to see. I can show you from here that how this one is bounded from above. So an is 2 raised to power n minus 1 by 2 raised to power n. So this is 1 minus 1 by 2 raised to power n. So this is clearly less than 1. The same logic applies here because 1 by 2 raised to power n obviously is greater than equals to 0. So this is similar, this was similar to the previous question. So an is less than 1 for all n, therefore this is bounded from above, right? So yeah, so I'll take up your doubts in the last 5 to 10 minutes of the class. Those who are still not clear about boundedness or non-decreasing, because these three questions we did for boundedness and non-decreasing, and all of them we are getting as convergent. More examples you will have in the book and in the tutorial sheet. तो जब आप खुद प्रैक्टिस करोगे आपको क्लियर हो जाएगा ये कॉन्सेप्ट और भी ज्यादा. And tutorials is also meant to clear your doubts, so you can also discuss in detail in your tutorial class. But I'll take your doubts definitely after in the last 5 minutes. So check the same sequence for non-decreasing also. So that's a task. You do that yourself. You check whether this is non-decreasing, and then accordingly you will see whether this is convergent or not. So yeah, so I'm going to finish this question here only, because that finishes the topic non-decreasing and bounded from above. And next thing we have to talk about is the limits. Yesterday I told you कि जो नॉन डिक्रीजिंग वाला मेथड है ये एक स्पेसिफिक मेथड है. अब नॉन डिक्रीजिंग वाले मेथड से भी हम सीक्वेंस की कन्वर्जेंस को आइडेंटिफाई कर रहे हैं. We are identifying whether a sequence is convergent by applying non-decreasing sequence theorem. But the limitation is, what is the limitation of this non-decreasing sequence theorem? The limitation is it is only applicable to the non-decreasing sequence. So that means अगर हमारा sequence non decreasing नहीं है, इस category में नहीं आता है, then we cannot apply this theorem to check its convergence or divergence, right? So but we should have a general technique which is applicable to all the kinds of sequences. So that technique is through limits, and it's very simple. You will see, इसमें कुछ नहीं करना आपको इस मेथड में. You simply evaluate the limit n tending to infinity an. So the question which I'm asking is, you are given a sequence an, and to check whether it is convergent or divergent. So I'm writing the short form of CGT, DIVGT. So this is convergent or divergent. What we have to do is, we simply, this is the step we need to do. This is just one step. You simply evaluate this limit n tending to infinity an, right? An की जगह पे substitute हो जाएगा जो भी आपको an general term given होगा, and then what are the possibilities for this limit? What are the values this limit can take? Yes, what are the possibilities for this limit? Yes, so you can write your answers here in chat box. The question is आप लिमिट जब भी इवैल्यूएट करते हो, जस्ट टेक इट एज अ जनरल क्वेश्चन, जब भी आप लिमिट इवैल्यूएट करते हो तो क्या क्या आंसर्स आ सकते हैं? It can be any real number, it can be a constant. I'm reading your answers only. It can be indeterminate form, it can be infinity, it can be minus infinity, it can be finite, unique, constant, it can be not defined. Yes, that is an answer. It can be any real number. Yeah, so I got your answers. Most of you have accurately verified that what exactly it is going to be. Yeah, so it can be any category, it can be not defined. So we know that when does a limit is not defined, we already know that. It can be a finite limit. Obviously we say the limit exists only if it is uniquely existing, because agar unique nahi hoga, so obviously that will go into the category of not defined. So when it is defined, it has to be this one of this case, finite or unique, or it can be infinity also, it can be minus infinity also, right? It can be an indeterminate form also, but indeterminate form is not an answer. These are the answers. You can write this limit is not defined, you can write this limit is finite and unique, you can write this is infinity, you can write this is minus infinity, means whatever be the final answer. So here your question finishes, और उसके बाद बस हमें इम्प्लाई करना है कि कन्वर्जेंस है कि डाइवर्जेंस है. आई एम कमिंग टू दैट, बट बिफोर दैट लेट मी टेल यू what happens when you write it is indeterminate form. So it can be infinity upon infinity, it can be 0 upon 0, it can be infinity minus infinity, right? It can be infinity raised to power 0, it can be 0 raised to power infinity. So all of these are indeterminate forms. So if it is indeterminate form, you cannot just write the question, you cannot just leave the question like that, you have to solve it further. आपको इसको आगे सॉल्व करना ही करना है टू गेट टू अ वन ऑफ द आंसर्स विच कैन बी एनी ऑफ दीज. वो फाइनाइट भी हो सकता है, वो इनफाइनाइट भी हो सकता है, प्लस इनफाइनाइट भी हो सकता है, माइनस इनफाइनाइट भी हो सकता है, बट यू हैव टू एंड योर क्वेश्चन एट वन ऑफ दीज फोर आंसर्स, राइट? सो ये जो है, अब ये लिमिट कैसे निकालनी है, सो अब हम बहुत सारे क्वेश्चंस करेंगे तो आपको वो सारे कॉन्सेप्ट रिकॉल हो जाएंगे, that whenever one particular kind of situation you face, how to evaluate that limit. So I told you yesterday also, you have to practice the calculation of limits. So assuming, suppose you know how to get the limit value, so what is the implication here? Now I'm going to write what you have to imply from what kind of limit, right? So the idea is, if your limit is finite and unique, then you have to write the sequences convergent. इसमें जीरो भी इंक्लूडेड है. डू नॉट गेट कंफ्यूज्ड कि जीरो हो सकता है कि नॉन जीरो. वी आर नो वेयर कैरेक्टराइजिंग बिटवीन जीरो और नॉन जीरो, वो कोई क्लासिफिकेशन नहीं है. जीरो भी इसमें इंक्लूडेड है, नॉन जीरो नंबर्स भी, नॉन जीरो रियल नंबर्स भी इसी में इंक्लूडेड है. finite and unique आ गया, चाहे zero है चाहे non zero है, तो then you just write sequences convergent, because convergence का मतलब ही वही था कि उसको एक रियल नंबर, एक लिमिटिंग वैल्यू यूनिक मिल गया जिसके अराउंड सारे नंबर्स, सारी सीक्वेंस की टर्म्स जा रहे हैं. So it's very easy, as you can see the method is very easy to imply convergence. हमने कुछ भी नहीं चेक किया सीक्वेंस an जो था नॉन डिक्रीजिंग था कि नहीं था. No need to check anything. You simply evaluate this limit. If the answer turns out to be finite and unique, you write the sequence is convergent. And if the answer turns out to be infinity or minus infinity, so in that case obviously you will be writing the sequence is divergent. राइट. इन्फिनिटी मीन्स कोई रियल नंबर नहीं है, उसकी वैल्यूज जो हैं बढ़ती जा रही हैं, सो इन दैट केस द सीक्वेंस माइनस इन्फिनिटी में भी वही होगा. बट नॉट डिफाइंड में क्या होगा, नॉट डिफाइंड में भी आप डाइवर्जेंट ही लिखोगे, क्योंकि only in this case, when the limit is finite and unique, then your answer is convergent. बाकी सभी केसेस में नॉट डिफाइंड है, इंफिनिटी है या माइनस इंफिनिटी है, योर आंसर इज डाइवर्जेंट. इनडिटर्मिनेट फॉर्म अभी इनकम्प्लीट है. इनडिटर्मिनेट फॉर्म को सॉल्व करके फिर आप किसी एक कैटेगरी में पहुंच जाओगे, या फाइनाइट एंड यूनिक पे पहुंचोगे या इन्फिनिटी पे पहुंचोगे, तो अकॉर्डिंगली फिर आप आंसर करोगे कि इज इट कन्वर्जेंट और डाइवर्जेंट. तो ये आपका फोर्थ मेथड मींस ये वाला जो मेथड है, लिमिट्स की सेंस आइडिया से आपको सीक्वेंस की कन्वर्जेंस डाइवर्जेंस आइडेंटिफाई करनी है. फ्रॉम दिस पॉइंट ऑनवर्ड्स सारे क्वेश्चन हम इसी मेथड से करेंगे. विल बी जस्ट सिंपली इवैल्यूएटिंग द लिमिट्स एंड इम्प्लाइंग द कन्वर्जेंस और divergence of the sequences. So before going ahead to the specific questions, so I'll just first discuss some limits. कुछ स्टैंडर्ड लिमिट्स हम डिस्कस करेंगे जो बहुत फ्रीक्वेंटली अराइज होती हैं इस पूरे चैप्टर में, सीक्वेंसेस में भी और सीरीज में भी, ताकि जब भी वो स्टैंडर्ड लिमिट्स आपको दिखे तो आप डायरेक्टली उनके आंसर्स लिख पाओ. वो मैंडेटरी नहीं है, कोई ऐसे हमें रट्टा नहीं मारना है, क्रैमिंग नहीं करना है. वी जस्ट नीड टू नो द बैकग्राउंड कॉन्सेप्ट कि कैसे इन लिमिट्स को सॉल्व करना है, सो दैट जब भी उस तरह की लिमिट आए हम डायरेक्टली उनको यूज करें टू जस्ट सेव द टाइम, राइट. So I'll be just listing few limits, and before that I'll be just asking you very simple questions. So all of you just solve this question and just let me know the answer to that. So अब हम just examples discuss कर रहे हैं limits का. अभी हम sequences से उसको connect नहीं कर रहे हैं, right? Yeah. So example. So just take first example. An is say n minus 1 by n. Very simple example. So all what you need to do is tell me this limit n tending to infinity. Yeah, so you are correct. This one is 1. So it's very easy to figure out. This was a very simple. हमने अभी question भी किया था. The limit is turning out to be 1 in this case. Right. So yeah, that's it. तो अगर अभी इसी question का अभी further answer करना हो कि ये जो sequence है as a sequence, वैसे अभी question नहीं पूछा गया convergence का, but immediately you can conclude that this sequence n minus 1 by n is going to be convergent. So you can see checking convergence divergence is so easy. सिर्फ limit निकालना है. तो अगर आपको limit निकालना आता है, you are through this kind of questions, and you just need to write which turns out to be finite and unique. Therefore, this sequence is convergent. And let's take another example. 4 minus 7. Yeah, so you just tell me the answer of this. Yeah, this is easy to see. Minus 7 n raised to power 6 plus 4 by n raised to power 6 plus 3. So This is minus 7. This is going to 0. So all of you know how to evaluate limits at infinity. हम n की नेगेटिव पावर्स ले आते हैं, मींस जितनी भी न्यूमरेटर या डिनोमिनेटर में n की पॉजिटिव पावर्स होते हैं द मैक्सिमम पावर से हम डिवाइड कर देते हैं सो दैट जब जो भी 1/n इस तरह की टर्म्स आए, जैसे यहाँ पे आई है 1/n⁻6, so obviously that will go to 0 as n goes to infinity. So clearly we can see, sorry ये मैंने गलत लिख दिया, -7. Yeah, this part will go to 0, this part will go to 0, so this is -7. So हर एक का लिमिट निकालने का अपना अपना तरीका होता है. You have practiced lot of techniques to evaluate the limits, but now you need to just practice. A detailed calculation needs to be shown. Do not just do it in your head and simply write the answer, although your answer might be correct, but try to elaborate your calculation so that we'll have more clarity about actually what we are doing in calculation of those limits. So these were very simple 2 questions I gave to you. So let me see whether I have, yeah, I have these 2 more questions. Wait a minute. Let me just. Try this one. The poll is not getting launched. I don't know what is the reason, but okay. If it does not get launched, I'll write the questions explicitly, which we need to do that. Yeah, I'm trying to do the question in poll, but due to some technical reason, the poll is not launching. So let me write the question for you. This is the question. The third example, an is n square minus 2n plus 1 by n minus 1. This is one question, and this is another question. An is log n square by n. So for both of them, you have to tell me. Yeah, I think now you are able to see the questions in poll. Are you able to see the question in poll? Yeah, if you're able to see that, you can answer in the poll. If you're not looking at in the poll, because it's showing me that you are able to view that. Yeah, I got that. So you answer for both the questions. Just calculate the limits. Take 1-2 minutes because this is not going to take much time. ये सारे देखो उसी तरह के एग्जांपल्स हैं, मींस लिमिट्स आप लोग बहुत डिटेल में करके आते हो ऑलरेडी. सो ये सब उसी का रिवीजन है एंड यू विल सी नाउ फ्रॉम दिस पॉइंट ऑनवर्ड्स हम हर क्वेश्चन में लिमिट से निकालेंगे, तो आपकी सारी रिवीजन हो जाएगी कॉन्सेप्ट्स की. जिस पॉइंट पे भी आपको लगेगा कि आपको कुछ क्लियर नहीं है, कोई लिमिट पर्टिकुलरली किस तरह से निकालते हैं, सो विल डिस्कस देम. मींस आई विल बी एक्सप्लेनिंग ऑल द क्वेश्चंस ऑल्दो. Yeah, so take 30 to 40 seconds more and then we'll discuss the answers. Do not guess it. Take your time to do the calculation. Okay, giving all of you 1 more minute because most of you have not answered it yet. Just giving you 1 more minute to look at that. Yes, Agrim, do you have a doubt?
Yes, ma'am. Earlier I had. Yes, ma'am. Ma'am, I wanted to ask that the 75% attendance rule is only applicable to the lecture class or also to the
Combination.
tutorial and practical classes
Yeah,
also.
every class, every class.
Okay. Thank you, ma'am.
Lecture also, tutorial also, practical also.
Thank you, ma'am.
Yes, Abhinav, you have a doubt?
Yes, ma'am, I had one before. I was a little bit confused between at what point do we have to use this non-decreasing sequential theorem and the limits one. So I just want to confirm this one thing, that we use this non-decreasing sequential theorem only when we are sure that the sequence we have is non-decreasing, right?
Yeah.
Yeah, but the limits method is universal. We can even use it to check whether it's bounded or not.
Yes, actually, yeah, but सी बाउंडेड का अलग से क्वेश्चन जो होता है वो लिमिट से इम्प्लाई नहीं होता है
Okay.
वो नॉन डिक्रीजिंग में कनेक्शन है लिमिट और बाउंडेडनेस का बट इन जनरल अगर आप सपोज जैसे अभी लिमिट्स निकाल रहे हो इन क्वेश्चंस की तो उस लिमिट का उसके बाउंड के साथ कोई कनेक्शन नहीं है बिकॉज हमने वो फंडामेंटल तो चेक ही नहीं किया ना कि एक्चुअल में ये बाउंडेड है कि नहीं तो आप बाउंडेडनेस को तभी पिक्चर में लेके आओ जब आप एक नॉन डिक्रीजिंग का क्वेश्चन कर रहे हो क्योंकि वही उनके कनेक्शन है थ्रू लिमिट अदरवाइज इंडिविजुअली लिमिट और बाउंडेड का कोई कनेक्शन नहीं है
Okay.
राइट तो माय सजेशन इज आप नॉन डिक्रीजिंग सीक्वेंस थ्योरम तभी लगाओगे जब आपको बोला जाएगा आपकी स्टेटमेंट में बोला होगा कि चेक वेदर दिस इज नॉन डिक्रीजिंग और नॉट एंड कैन यू अप्लाई द थ्योरम इफ द क्वेश्चन इज सिंपली चेक वेदर द सीक्वेंस इज कन्वर्जेंट और डाइवर्जेंट तो आप अगर नॉन डिक्रीजिंग वाले मेथड से जाना चाहते हो और अगर इट हैपन्स टू बी एक्चुअली नॉन डिक्रीजिंग और बाउंडेड फिर आप कर सकते हो बट अदरवाइज डायरेक्टली द लिमिट मेथड विल बी एप्लीकेबल
Okay. Thank you, ma'am.
Yeah, so yeah, I'm going to end this poll and let's see the results. I think most of you have answered. Yeah, so these are the results we got for question number one. The answer is given by 74%, which is right, infinity. And for question number two, yes, the answer is zero. So I'll just very quickly show you the calculations of both of these questions. So जिनका गलत आया है वो क्यों आया है they can very see what wrong they were doing. So it's simply वैसे तो ये देखो ये एक रैशनल फंक्शन है रैशनल फंक्शन होता है पॉलिनोमियल डिवाइडेड बाय अनदर पॉलिनोमियल सो ऊपर पावर ज्यादा है यू कैन से एन स्क्वायर है नीचे एन रेस्ट पावर वन है सो इसका आंसर इन्फिनिटी आएगा यहीं से पता चल रहा है बट लेट्स जस्ट डू प्रॉपर कैलकुलेशन तो आप एन स्क्वायर से डिवाइड करोगे सो देन यू विल गेट वन माइनस टू बाई एन प्लस वन बाय एन स्क्वायर और नीचे भी एन स्क्वायर से ही डिवाइड करोगे ओनली देन इट विल मेक सेंस so that will be 1 by n minus okay let's not do it this way means you just need to do आप इसको n से डिवाइड करोगे वैसे भी आ जाएगा वो अल्टीमेटली वही करना पड़ेगा so then you will get this yeah this is easy to understand this way ऐसे भी आपको फिर से n ऊपर लेके जाना पड़ेगा whatever so this answer is infinity because these terms will go to zero and you are having a positive power of infinity so infinity raised to power 1 is or infinity raised to power something positive is infinity तो ये infinity है वैसे भी ये यहीं से देख के पता चल रहा है because ऊपर पावर ज्यादा है n की नीचे पावर कम है for a rational function whenever you have to take a decision so it's infinity it's clear for these kind of questions I just ask you this clearly infinity goes to infinity and raised to power 6 by n cube plus 1 minus 20 whatever you write this will also go to infinity so all these questions जब ये powers इस रिलेशन में होती हैं ये इस तरह के फंक्शन के लिए है रैशनल फंक्शन कि ऊपर भी पॉलिनोमियल है नीचे भी पॉलिनोमियल है उस केस में यू कैन ऑलवेज डिसाइड जस्ट बाय लुकिंग एट द पावर्स and do the calculation you will get the answer to be infinity and for this one It is infinity by infinity. As you can see, indeterminate banega because log infinity is infinity and n is infinity. If I write it properly, this will be indeterminate. So in this case, I have to use L'Hopital rule. So whenever your indeterminate form is infinity by infinity or 0 by 0 form, in that case, you have to use L'Hopital rule. So what does that rule say? You have to differentiate above, right? So you will differentiate above with respect to n. So that will be 2 into the derivative. आप इसको पहले break कर सकते हो. Yeah, what you can do is, what will be the derivative of that? 1 by n square into 2n, because log का derivative will be 1 by x, and then n square का derivative will be 2n, and n का derivative is going to be 1. So this is going to be 2 by n, and this will go to 0, right? Or you could also write it this way, 2 log n by n, फिर इन्फिनिटी, बिकॉज एन स्क्वायर जब ऐसे लिखा है तो इट कैन कम इन फॉरवर्ड. तो यहाँ पे भी आपको पता है log n by n दैट विल बी infinity by infinity. अप्लाइंग L'Hopital रूल यू विल गेट 0. तो जैसे भी करो अल्टीमेटली उसका आंसर 0 है, एंड एक बार तो L'Hopital यूज होगा ही होगा बिकॉज इट इज कमिंग ऑफ दिस फॉर्म. सो द करेक्ट आंसर इज 0. सो यू एक्सप्लोर दिस टास्क. ये सारे 0 आएंगे. मैं कितनी भी बड़ी से बड़ी पावर आपको दे दूं, ये सारे 0 ही आएंगे बिकॉज अल्टीमेटली दैट पावर जस्ट कम्स इन द फ्रंट. विल हैव फ्रीक्वेंट दीज काइंड ऑफ लिमिट्स, सो देयर यू कैन सी ये सब ऑब्वियसली एज n goes to infinity, right? Yeah, so right now I think the concept of limit is clear to all. We'll have plenty and plenty of examples to practice this limit concept, right? So hold on your doubts for tutorial class and the next class.